So this is the last lesson in Unit 1. After this, we'll be doing review. And the first thing we're going to look at is how to tell whether a function is what's called even or odd. And it has to do with the symmetry of the graph. So an even function is symmetric to the y-axis. If there's symmetry to the y-axis, it's called an even. And so if you have a graph, you can just look at it and go, oh, I see the symmetry. You don't have a graph, you have to figure it out algebraically. And the way that you do that is you plug in negative x. If it comes out to exactly what you started with, like the original function, then it is even. Here's the thing, when you go to work these out, and I'll say it again when we get there, people plug in negative x and try to like force it to turn out a certain way. Don't do that. Just see what happens. All right, it's a test. You're testing what's going to happen. So an example of an even function would be like the quadratic function, something that looks like this. So symmetry to the y-axis. So what's in quadrant 1 here is symmetric to what's in quadrant 2. So it's nice if you have a graph, you can just look at it and go, oh, I see the symmetry. It's an even function. Odd function, and then someone always wants to say it's symmetric to the x-axis. It's not. Let's talk about why that's not even possible. How come I couldn't have symmetry? This would be symmetry to the x-axis. Why is this like a no-no? It doesn't pass your vertical line test, so it's not a function. So an odd function means symmetry to the origin. Symmetric to the origin. And so the way that that looks visually would be like the cubic function. So you have symmetry to that point 0, 0. So what's in quadrant 1 is reflected down into quadrant 3. And so again, if you don't have a graph, you have to figure it out algebraically. It's the same test. If you plug in negative x, and again, don't try to force it to turn out a certain way. It's a test. You're seeing what happens. If you get back the exact opposite of what you started with, negative function, or I say negative, meaning opposite, the exact opposite of what you started with, then it's odd. And that's kind of nice as far as remembering because they both happen to begin with O. If you get the exact opposite, then it's odd. So it's kind of nice just how it worked out as far as our language. So we're going to test these ones, 1, 2, 3, and 4, algebraically. You don't have a graph. So we're going to plug in negative x and just see what happens. If you get the same thing you started with, it's even. If you get the exact opposite, then it's odd. All right, so everywhere that there is an x, you're going to put a negative x, or kind of like an opposite of x. Give them all a hug. You need parentheses around everything that you're plugging in. So it's negative x squared plus 5 negative x. Yes, bless you. And then you just see what happens. All right. Now, negative x squared, that means negative x times negative x. You have 2 of them. So what's going to happen there? It's going to be positive. So that would be a positive x squared. And then you have 5 times negative x, which will be what? Negative 5x. Good. So this is what we ended up with. You don't want to try to force it to be anything. That's just what we got. Now you want to compare it to the original problem, term by term. All right, the first term, it was an x squared, it's an x squared. That's the same. The next term, we had 5x, now it's negative 5x. So one term was the same and one term was opposite. So this would be neither. We didn't get it completely the same or completely opposite. Like one term was the same and one term was opposite. So it's neither. Does that make sense? Like if it doesn't come out to either option, then it's neither. All right, so let's try that again. We're going to plug in negative x. Again, give it a hug. Everywhere that there's an x, you're going to plug in a negative x. Means that there's 6 of them. So again, what's going to happen? Good. Why would it still be positive? That's a good way to say it. I like that. There's 3 pairs of them. You see how these ones will cancel, these ones will cancel, these ones will cancel. So if you have even power, it's going to be positive. However, we then multiply it by a -3. So this part is going to be a positive x to the 6, and then we multiply it by a -3. So it still comes out to -3x to the 6 because of that negative that was out front. So you want to compare that to what the original problem was. What do you notice? They're the same. So we're going to say it's even. And if you were to graph that, there would be symmetry to the y-axis. I'm not going to make you graph it, but if you did, that's what we're saying. All right, again, number 3, we're going to plug in -x. So everywhere that there is an x, you're going to plug in an opposite of x. I'm saying negative, but it means opposite. Whatever you had, make it opposite. That'll be negative. So this will be a -4x to the 9th. Here's the common mistake. Don't write this on your paper because I have to mark it wrong. People will write this. And I get what you're trying to say there, but the negative has to go in front of the whole term, because what does this mean? Because it's not technically the same anymore. It's not a -4x to the 9th, it's a 4 minus. Do you see, like, it's not the same thing. So just make sure you put your negative sign out front, because I don't want to have to mark it wrong. Like, I know what you're trying to say, but it's not, it doesn't mean the same thing. All right, so -4x to the 9th plus a -x would just be -x. So you want to compare that to the original problem. Did it come out the exact same, exact opposite, or like a mixture? Opposite, which means odd, which again, that's kind of nice just as far as our language works. They both start with O, so it helps you remember. All right, now let's try one more. Again, give them all a hug. Everywhere you see an X, you're going to put a -x. Oh, and I made this one almost the exact same as number 3. I just changed one little thing. The only thing that's different is I put that +2 at the end. So when you do this -x to the 9th, that's going to come out negative. So -4x to the 9th minus x, and then I stuck that +2. The +2 is not going to change because that part's constant. There's no variable with that. So when you go to compare, first term's opposite, second term's opposite, but that 2 is the same. So what's our conclusion? Yeah, neither, because some of the terms were opposite and some of them were the same. So you can, change it just by sticking a constant at the end, like that +2 threw the whole thing off and it ended up being neither. And then these ones we're going to look at just visually. So what do you think about number 5? Is there symmetry to the y-axis, the origin, or neither? Yeah, good. Symmetry to the y-axis. You see that there? You could flip this over. So that one's even. And how about number 6? Looks like the Big Dipper. Yeah, neither. There's no symmetry there. And then 7 is odd. And then these ones, I'm not going to make you graph them. I want you to use your imagination. Do y'all have your imagination turned on? Okay, you all look very awake for Monday mornings. Good. We're going to label the parent function, so not transformed. Think about the parent function as even, odd, or neither. Constant. Even, good. Linear would go through the origin and have a slope of 1. How would that look? Let me go this way for you guys. Odd, good. This is hard when you're not looking at it. You have to imagine it. It's difficult. Quadratic. Even, yeah, I should do that one. Square root. That's neither. Good. Awesome. Cubic. Wiggle is odd. So cube root would also be odd. So the cubic graph just turned on its side. Absolute value. Even. Rational. It's got those invisible fences, the asymptotes, and looks kind of like an hourglass. Good. Odd. Yeah, what's in quadrant 1 reflects down into quadrant 3. Exponential. It's neither. And logarithmic is also neither. All right, so the last thing that we're going to do is just evaluate functions. Evaluate means you're going to take a value or an expression and plug it into the function for x and then see what you get. All right, so number 9, and we're going to use the same function for all of these right here. So we're just going to plug 4 into that function for x. So it would be -3 times 4 plus 7. It's an input-output thing. It's if we plug in 4, what do we get back out? So what's that going to give it? And this is what you got to be able to do without a calculator. What's that going to come out to? That'll be -12 plus 7. So -5. So if I made you graph this, which I'm not going to do, but if I did, the point 4, -5 would be on the graph. You input 4, you get back -5. Are you coming with me on like what that means? So I don't want you to just do this and have no idea what we're talking about. It means the point 4, -5 would be on the graph. All right, same thing with -1. You're just going to plug in -1 for x. You want to give it a hug, put the parentheses around. And then again, you got to be able to do that without a calculator. So what's that going to come out to? Yeah, good. It'll be, I'm going to write out the middle step so it's on here. 3 plus 7, so 10. Right, 11 says negative function, negative f of x. So you want to put a negative and then give the entire function a hug. So that -3x plus 7, just put parentheses around that whole thing and stick a negative out front. We're just oppositing the whole function. I know oppositing isn't a word, but negating the whole function. So you would just distribute a negative through there. It's like opposite day. Every term is the opposite of what it was before. It's like you're making the function odd. So it would be 3x and then minus that. So do you get the difference when the negative's outside? It goes outside of the whole thing. Because this is -2x that's inside. You want to plug -2x into the function. So where there's an x, you're going to put a -2x. So this won't come out to just a number. You're going to have a variable in there. And so what is this going to be? Good, 6x plus 7. Nice. I like how you describe your yes or no. It's a very yes. I like that. All right, and then this is just the function plus 2. So you're going to take the function and then stick a plus 2 at the end, which you could pretty much do that in your head if you didn't want to write out the middle step. I'm just writing it all out for you. So it'll be -3x plus 9. And then we're just going to practice the same thing. We're going to use this function. Now this one has a squared in it, so it's just a little bit more to it. You know, call it a harder problem. It's just a little bit more to it because of the square, but same idea. All right, so here we're going to plug in a -3. So -3 squared be +9. Double that would be 18. -4 is 14. So again, we input -3, we get back 14. That means that coordinate pair would be on the graph. You guys go ahead and try this one. Try f of 5. Plug 5 in. So 5 squared would give you what? 25, double that, 50, and then 50 minus 4, 46. Good. Are you guys getting there without the calculator? Are you understanding like the extent of what you have to do? It's not as bad as you were worried about, right? I'm going to keep the number small for you. All right, f of -x, that's exactly what we were doing on the other side of the paper. It's basically testing whether it's even or odd. You're going to plug in -x. You square that, it will come out positive or negative. Good. If you take something to an even power, it's going to be positive. So that'll be a 2x squared minus 4. And so it wasn't part of this question, but I'm going to ask you anyway, is this function even, odd, or neither? Yeah, even. Came out the exact same. All right, this one says 3f of x. That's like what we did up here with the negative f of x. We just stuck a negative in front of the whole thing. We're just going to stick a 3 in front of the whole function. Basically, just distribute a 3. It's a vertical stretch by 3. What's going on there? So distributing the 3 through there, that'll give us 6x squared minus 12. I sometimes get asked here, do we need to factor that? And the answer is no, because if you did factor it, you would end up with, like, you would undo what you just did. Do you see what I'm saying? So no, don't factor these. All right, I saved the toughest one for last. This is f of x minus 6. We're going to plug x minus 6 into the function. Now here's the common mistake I get on this one. So don't write this. I'm going to show you what's wrong, okay? When people do this x minus 6 squared, they like distribute the squared, and so they get x squared minus 36. Or if you do want to write that on your paper and remind yourself that it's wrong, like don't do that. That's what not to do. When you do, you know, x plus or minus something squared, you have to write it twice. Squared means that you're multiplying it by itself, so you have to write it twice. Ms. Cole, that's a lot to write. You have to write it twice. Work with me, people. It's not that much. Like we were just talking about, you're going to write way more in history and English class than I'm asking you to do. So just write it twice. And then I call this FOIL, first, outside, inside, last. Have you ever had a teacher use that acronym with you? Or, well, some of you maybe. If you haven't, it's just a way to stay organized. You're going to multiply, this 2 is going to just kind of hang on there. You're going to multiply the first terms, then the outside terms, then the inside terms, then the last terms. It's just a way to stay organized. So let's do the first. X times x. X squared. Good. Now I encourage you to do the outsides and insides together because they will combine. The outsides are going to give you minus 6x, and the insides are going to give you minus 6x. So if you have minus 6x and minus 6x, what's that going to be? Yeah, good, minus 12x. It's like you owe someone $6 and then you owe them $6 more. Now you owe them 12. And then negative 6 times negative 6 is positive 36 because the negatives cancel. And I'm sorry about the hole in the paper then. All right, but that was the toughest part. You just have to write that out. It's first, outside, inside, last. You're just distributing everything, right? And now we're going to distribute the 2. So that'll be 2x squared minus 24x plus 72, and then that minus 4, again, I'm sorry about the hole in the paper, minus 4. And then you're going to combine the 72 minus 4, which will be 68. So that was a little bit more writing, but here's my pep talk for that. It was more writing, but was it really hard? No, you just have to multiply small numbers together. Again, if you can multiply and add, you're going to be okay. It's more about not being lazy. Like you just have to write it out. It's more about organization than intelligence. You just have to be willing to write it. And then here we're going to evaluate these without an equation given to us. We're just going to use the graph. So when this says f of negative 5, what it's really asking you is we have the point negative 5 comma what on the graph. And remember, you can only get one answer, otherwise it wouldn't be a function. So you find negative 5 on the x-axis, which is right here. And you find where that point is on the graph. And I'm just kind of bolding it for you. So here's negative 5. What does that give you as an output? Yeah, good, 4. The point negative 5 comma 4 is on the graph. And we're just going to do that same thing for all these. It'll be negative 2 comma what? Yeah, negative 2. That one already kind of is bold for you. All right, f of 3. Yeah, that's also negative 2. Good, don't let that fool you. That's constant right there. F of 4, this one's a little tricky. Good, why is it 1? Yeah, the hole doesn't count, it's where the filled in circle. And then last one, f of 7 is 4.